In this session, what we're going to do is we're going to take a deep dive into Sentinel. We're going to have a look at what it is, we're going to look at how it works, and we're going to look at some of the rationale behind it when we were designing the language. We're going to look at what policy as code is and why it's actually really important for us to use it. And we're going to have a look at the language specification and some of the ways that we've tried to make it non-programmer friendly and really, really, really accessible. So first things first, why policy as code? So I think we've got to understand what policy is. So straight out of the dictionary. So policy is a course of principle or action proposed by an organization or an individual. So why does that matter? Now, organization of policy matters, and it doesn't matter what size you are. It doesn't matter whether you're a small organization. It doesn't matter if you're a big organization. It's a thing that kind of governs our daily activities. So for example, we might have a policy which controls when we can deploy code into production. We might say that we can only deploy Monday to Thursday between, 8 a.m. and 4 p.m. Now that's a simple policy. We can probably manage that policy with a common understanding. We can probably transfer that understanding through communication. But it's really difficult to codify that. There's no real standard way to codify that. And as our companies grow, as our teams grow, then sharing that common understanding again becomes more complicated and difficult. And it also depends on the importance of the policy, and I think this is a key thing. So if we're talking about a deployment pipeline, then that's one thing, but what if we're talking about a regulatory policy, something which is really, really, really important, something which you can't necessarily manage with just like an informal channel or communication. So what we start to do is we start to build up all of this policy, and it very quickly starts to get very complicated. There's a lot of exceptions, and it becomes a huge cognitive load on the operators. So we document it, but again, there's no real standards around this documentation. We can kind of try and store it in a central location. And this helps with the sort of the definition and the understanding, but how do we deal with the automation? We need to be able to enforce policy. Just documenting it is not enough. So we try to codify it. There's various different methods we do. We might build some stuff into deployment pipelines, but it's all a little bit ad hoc, and there's no real central standard, no real method that we can all get behind. And that's complex. It's error prone. And in the case of regulatory, it's not acceptable. So for these reasons, HashiCorp created Sentinel. And Sentinel's a language which allows you to write policy, and it's both human readable and machine parsable. Because it's machine readable, we can integrate it directly into our product suites. So that means the products you're using today into Nomad, into Vault, into Console, into Terraform. And writing policy as code means we can treat it like an application. So we can version control it. We can do things like code reviews on the policy. We can write automated tests about our policy. And we can use real programming constructs to determine these policy decisions. And this is all beyond the bounds of a typical ACL system. Now, with kind of fine-grained condition-based policy, what you get is that any available input can be used. It doesn't have to be this kind of like coarse-grained read, write, or admin. We can make policy decisions based on the conditions of other values. And Sentinel is embedded. And what that means is that we can enforce the policy in the data path. We're going to actively reject an action based on policy when we're not just kind of passively detecting it. And we've got multiple enforcement levels. So we've got the capability of advisory, soft mandatory, hard mandatory, and these are important because rarely policy is clear-cut. There's always an exception which we need to consider. So when we're integrating it with products, what Sentinel can do is it can source external information around these policy decisions. So for example, Terraform cannot execute while console health checks are failing. It allows you to build up these really rich scenarios. And it's multi-cloud compatible. This ensures that our infrastructure within business and regulatory policy on every infrastructure provider is covered. You can write your policy for your deployment process in Terraform, and every time you run Terraform plans, Sentinel will check. You can write your policy for Nomad, and every time you scale a job or run a new job, again, that policy is checked. You can write a policy for Vault, which is monitoring the various API calls. You can ensure that your company is adhering to the set agreed limits around TTLs for secrets. And you can write a policy for console, which allows you to kind of implement that internal structure around what are we going to namespace, how are we going to name our keys, how are we going to name our services. It's really rich, and what you can do with Sentinel and how it integrates is entirely up to you. It's how you build, what your needs are for your particular use case. So with that, let's have a look at the Sentinel language and see how we can write this policy. So one of the key things that we looked at when we were kind of designing Sentinel, again, and I'm going to sort of iterate this, is that policy has to be understandable by both humans and parsable by computers. And the sort of policies that Sentinel encourages or advances, they contain logic and also potentially state. So in the end, we decided that actually what we need to do is we need to build a custom DSL to achieve this. And let's kind of have a look at the goals we had for this language and why this led us to that decision. So we had these 5 language goals. Sentinel had to be non-programmer friendly. Sentinel needed to be embeddable. It had to be simple. It needed to be debuggable. And it had to be Go friendly. So for a large percentage of real-world use cases, the language needs to be learned and it needs to be written by somebody who's maybe not so familiar with programming. Now, it's expected that in some of the advanced use cases, you can use sort of traditional programming constructs. And kind of embeddability, you know, it's not really so much a trait of the language, but the runtime. But it was really important to us that the language didn't support unsafe operations. It didn't support things like direct memory access. You couldn't do things in the standard library like sub-process execution. And it had to be simple. You know, policies are generally kind of small. They don't require a lot of system flexibility. And when we looked at kind of many programming languages, we kind of looked at things like, well, you've got complex types, you've got multiple different types of integers, and you've got differentiation between signed and unsigned. And when we looked at that for policies, we were like, well, do we really need that? We really wanted the types that were going to be exposed and used in Sentinel to be simple. We wanted to have integer, we wanted to have float, we wanted to have Boolean values, strings. And this came at an expense of sort of performance and precision, but it enhances the key thing, which is the readability. And debuggable. I mean, this goes hand in hand with non-programmer friendly, but we wanted a language which was easily debugged. We wanted to be able to test policy, and we wanted users who are not necessarily comfortable with writing code to be able to do this. And Go friendly, this might have been a little bit of a selfish one, but you know, most of our products are written in Go. We needed Sentinel to be easily embedded in those products. And actually, if you take a look out at this DevOps ecosystem, then quite a lot of DevOps software these days is written in Go. So embeddability was a big deal. So why didn't we just use JavaScript or Ruby or Python or Lua? And we did actually spend quite a bit of time looking at this, and we didn't necessarily think first, let's go create a specific language or a DSL. But each of the existing languages had their own kind of problems with the 5 language goals that we had. But one of the main issues was around embeddability. So if we wanted to use a pre-existing language in Go, we would have to use external bindings. And so from a technical perspective, that's kind of a reasonable compromise, but it doesn't really allow embeddability in the real world, which could help take on the adoption. And another issue was non-programmer friendliness. So when you look at the types of policy that you're writing, so languages like Python are super user-friendly, they're pretty attractive to use, but it just felt a little bit overblown for what we actually needed and able to author policy. And yes, if we'd used Python or something like that, then some users may be familiar with Python, but actually there's still going to be a requirement for learning. And most importantly, the security. So if we'd taken a standard language and we tried to embed that, then we have to lock it down. We have to try and build a sandbox around that language to stop the things like memory access and sub-process execution, which were one of the goals. When we start with our own language, we're starting from a point of least trust. We're at that immediate and dynamic typing. So Sentinel's dynamically typed. We kind of wanted to do static typing in Sentinel. That was one of the original things, but unfortunately there's kind of the major problem with static typing around Sentinel was all of the different types of external data that we use. So things that come from Terraform Plan, things that are around validating jobs with Nomad, API calls to Vault, all of these would have had to specify their types and their structures, and this was a problem with embedding. So with the dynamic typing, you can get runtime errors. If you try and add a Boolean and an integer, that's going to cause a runtime error. But the way that Sentinel handles this is that a runtime error results in a denied policy. And of course, dynamic typing makes things extremely programmer friendly. So using a simple example of a deployment window, we can write a Sentinel policy which looks like this. Now the main construct is a rule, and a rule is a lazy sort of memoized expression, and the contents of the rule are only evaluated when they're needed, which gives us a performance boost. You got to remember that the policy execution is happening in line as you're performing the action on the various endpoints of the software. And there's 2 main reasons why we kind of like rules. And function calls felt really programmery. You know, a complex Boolean expression, these kind of simple sub-expressions felt really sort of simple enough that we wanted to expose this. And it gives us this easier performance win. The simple hint allows us to do some really good optimization internally. And when it comes to things like operators and delimiters, so we've implemented all of the traditional programmer type operators and delimiters that you'd be used to in your languages. But what we also wanted to do was we wanted to implement something which was a little bit kind of more language friendly. So we have the options of like and or and contains and in and matches and not. And again, the main focus is on the readability. So using programmer representation like a double pipe for or, it kind of results in a higher barrier to entry. And it requires a higher level of understanding on the reader of the policy. So for example, I could write a policy like this. I could write that rule time.hour bang equals 3. But with Sentinel, what I can also do is I can write a rule like this. I can say that time.hour is 3. I can say that time.hour is not 3. So this readability allows non-programmers to use kind of grammatical terms that they're going to be more familiar with. And the else operator was a thing as well. I mean, we kind of, where possible, wanted to avoid people having to write really, really complicated logic blocks. So we introduced else, which gives you the option of returning a default value in the case of undefined. And on undefined, we introduced this as a special value. So undefined literally represents a result when the runtime can't kind of definitively or it can't safely return a value. So for example, here, if I'm trying to access an array index which is greater than the count of that array, that'll result in undefined. If I try to access a value which is null, that will return in undefined. And the reason that we have this is because it allows the policy to escape running on pure sort of logic. So if the job doesn't have this number of task groups, then that returns in undefined. But if the time is greater than 8, then actually this policy's still got the opportunity to succeed. If we'd thrown a runtime error, then this policy would have failed regardless. And the existence of undefined, again, introduces this lower boundary of entry for non-programmers and allows this policy to potentially succeed. Variables are first-class citizens, and we wanted to introduce variables to look at things like readability. So the example we were looking at before, I mean, that's quite readable if you're used to looking at sort of programming code, but when you start to write that and using variables, yes, the policy becomes more verbose, but it's actually reading more like you would write in a document or an email, and that was one of the key principles. And because we have dynamic typing, we don't need to kind of declare the type of variables ahead of time. So this variable here is just creating a list of string. I don't need to specifically ahead of time declare that I'm having a list of string. The assignment is setting that for me. And then we have imports. So we've got the capability to import features into your policy that you can leverage. So there's time, which allows you basic sort of time functions. You've got sock address, which allows you to sort of manage things working with IP addresses, such checking if something is IPv4 or IPv6. Simple convenience functions, which make life a little bit easier. And of course, you can import things like the console plugin to access the key value data. You can use the Nomad plugin, and you can be checking the various different attributes of a job. And the same goes for Vault and Terraform. So simplicity when working with collections was also an essential feature. And in this example, what I'm doing is I'm iterating over the resources that are returned from the TF plan. And I'm using the keywords all, and I'm using the keywords as. And what that allows me to do is I can evaluate true for absolutely everything. So it gives me that simple way of moving through collections. And around collections, what we did was we also introduced the keyword in. So I want to check in this instance if the machine type is in the list of allowed machine types. And I can do so very simply, not by having to iterate through the collection, but by using the keyword. And of course, we have contains too. So I've just kind of turned that expression on its head here, but what I'm now doing is I'm saying, does this array contain the value machine type? And when we started to use contains, what we actually found was that it was a pretty nice way to work. And why don't we extend contains out to a string? So I can say, does machine type contain a string value? Simple to write, easy to read. And then there's policy enforcement. So the integration of policy enforcement is done at a framework level. So we have advisory policies, and advisory policies are ones which never reject behavior, because when these policies fail, they'll either present the user with a prompt, or they will just kind of ignore and they'll log. Soft mandatory are those which will actively reject behavior. Now, the interesting thing about soft mandatory is that soft mandatory allows you to override this policy. So if you have privilege escalation, you can override a soft mandatory policy. The example of can we deploy out of hours? Well, if we had a soft mandatory policy, we would be able to do so because we can override it with a privileged account. Hard mandatory policies, on the other hand, can't be overridden. The only way to override a hard mandatory policy is completely remove it from the system. Okay, so this is the bit that I love, because this is the bit that always is a little bit stressful. We're going to do some live coding. And what I'm going to show you is I'm going to show you the Sentinel Simulator. So we've talked about policy. We've said that we need people to be able to write policy, and they need an easy way to do it. They need an easy way to test policy, to write potentially test-driven policy, and the Sentinel Simulator gives us that. It allows you to write those tests and execute those tests. It allows you to format your code. It allows you to sort of look at the docs. A really, really simple tool. So deep breath. Here we go. That's a good start. Okay, so what we're going to do is we're going to walk through creating a simple policy. So what I'm going to do is I'm going to create a new file. And I'm going to call it example.sentinel. So at the very basis of all Sentinel policy, you have a requirement to have a main rule. So I can write that like this. And that's the very, very most basic element of a Sentinel policy. Now, that's not a particularly useful rule because that's always going to evaluate true, so not a particularly effective policy. So let's import time and let's see if we can write that very basic deployment window. So again, I'm going to use import, and then I have the name of the import which I want, and I want time. And I'm going to say time.hour is greater than equal to 8. And I'm going to say time.hour is less than 5 p.m. because nobody wants to be deploying code after 5 p.m. And I can run that just using the command line tool. So if I run sentinel apply -v and the name of the policy, and we're getting a failure on that. So let's have a look at that. The curse of the live demo. Can anybody understand why time seems to be? Oh, is my computer gone crazy? But actually, this is a really interesting segue as to why. So the demo I was actually going to show you is I'm going to say, well, how do you test a policy which is running when you're out of the time? It's not appropriate to wait until after 5 p.m. to test a failing policy, right? Seems like it's done some of the work already for me. So let's look at how we would write a test. So what we do when we're writing tests is we follow a principle of convention. So for Sentinel tests, we have a test folder, which exists in the same location as our policy. And inside the test folder, what we do is we create another folder, which is the name of the policy that we want to run. And then inside of that, what I can do is I can create my policy. And the test files are written in JSON. So it's a very simple JSON format. So let's just add a fail. So in terms of the way that you author Sentinel tests, you've got 3 blocks. You've got the configuration, you've got mocks, and you've got the assertions. So if I write config block, and I want to set some config on time, because that's a plugin that I'm using. And what I'm going to do is I'm going to set the time zone. And I'm going to set the time zone to UTC. And I'm also going to make sure that I'm correcting typely JSON there. So then what we need to do is we need to kind of set up a mock. So I need to be able to set up a sort of a condition that time is what I want it to be for my assertion. So let's write a mock. So again, we're going to use the mock block. And we're going to mock time. And I want to mock the parameter hour, yeah. And I'm going to set it to, let's set it to 1800. And then finally, I'm going to write my assertions, my tests. So again, I'm going to use the test block. And to write an assertion, it's basically, I just write a simple key value with a Boolean expression for my rules. So I want to test the main rule, and I want to test that it's false. So again, back to the simulator, what I can do is I can use the simulator command test. So Sentinel test, I'm going to specify verbose output, my Sentinel file, and my test is passing. And my test is passing correctly because it's saying that time.hour is not less than 17, because I said it in the mock to 18, and that's as expected. So what I can do is I can create my passing test. So I'm just going to copy that. I'm going to call it pass. And I'm just going to change this to true. And I'm going to set the hour to within our bounds, so I'll set it to 10. And I run that again, and now we've got 2 passing tests. So if I just quickly change that, change my assertion so I can get the test to fail, and you'll see that the test is correctly failing now. So this gives me a really simple way to write my policy and to check that they're true. And with the mocks, you can basically replace any of the real sort of structures that are coming out of the products like Terraform or Console. Now, why that's really important is it gives you the capability of doing a CI-based workflow. So what I've done is I've added a whole bunch of policy to GitHub. And because it's stored in GitHub, I've got that capability, I've got versioning, I've got pull requests, and I've got continuous deployment. So with continuous integration, what I can do is I can run the Sentinel test command in this instance I'm using Travis. But because if a policy fails, it's going to return an exit code 1, then that's going to fail my build. And because we're outputting to the standard out, the log, I'm going to be able to see all of that. So that gives you that full workflow. You can truly treat your policy as you would do as code. And it's pretty simple to set up. I mean, there's not a lot sort of going on there in order to get this to work. I'm pretty much installing the Sentinel binary on Travis, and then I'm running Sentinel test. But let's have a look at how we can use Sentinel in a real application. Maybe. So I've got Nomad Enterprise, the latest beta, running here. And I've already pre-configured this with the ACLs. So if I have a look at a job that I have a fairly straightforward job, which is just going to run a couple of web servers. And I have a policy, and the policy is just going to say, well, I've got this deployment window, and I also want to ensure that the size of the deployed web application is going to be between 3 and 24 in size. So my main rule is evaluating that the deployment window is open and that the job count is valid. So to deploy a policy, all I need to do is I need to use the Sentinel subcommand on the Nomad binary, or I can use the APIs. And I'm running Nomad Sentinel apply. I'm specifying the level. So I want, remember the 3 levels we talked about? I want a soft mandatory policy. I want it possible to override this one. I'm going to give it a description which makes it a little bit more human readable. I'm going to give it the name. In this instance, I'm calling it very imaginatively jobs. And the name of the policy that I want to apply. And that's successfully written that into Nomad. So if I list those policies, you can see that I've got one policy there. It's called jobs, it's a submit job. So scope isn't something that we've covered, but a policy can also apply to a scope. So at the moment in the Nomad beta, we have submit job as a scope, but potentially you'll have things like scaling, canaries, and all sorts of features. Now, if I run my job, Nomad run, then that runs fine, because what I'm doing is I'm scheduling 3 instances of my web endpoint. And you can see all 3 are running there. But what actually is happening today is that we kind of are releasing some new products. So we need to scale up the number of endpoints we've got. We can't just run 3. We need 30 endpoints. So let's change the Nomad job, and we'll up the count of the web front end to 30. So when I'm doing this, I decide to change it to 30, and what I actually do is I change it to 2 because I make a fat-fingered mistake, which is fairly easily done. And when I run that policy again, what you can see is it's now failed. So because I've got that policy loaded inside of Nomad, Nomad has stopped it right in the execution path. And the output that it's given me, it's telling me that the policy has failed because the count isn't greater than 2. So let's go back and we'll change that to 30 as it should be. And we'll run that again. And it's failed again. And this time it's failed. It's not because I've made that fat finger mistake. It's failed because my threshold is stating that I can only have a maximum of 24. But because this is a soft mandatory policy, what I can actually do is I can override it. If I knew somebody with privilege, which I just happen to do, if I could, there we go. So to do the override, again, because I've got the ACL enabled in Nomad, I'm going to be using a token which has higher privilege escalation than my normal user token. And I'm going to run the job again, but this time I'm going to specify policy override. And I run that. And that was a little bit quick to see, but that's passed. Because the yellow output that you saw there very momentarily isn't that the job has been denied, it's that it's warning me. So Nomad's still warning me that my job is out of tolerance, But it's allowed me to succeed because I've overridden the standard. And that's actually deployed. So if I look at my Nomad status, I now have my 30 allocations as I wanted. And our big product release will be okay. So that's it, really. I mean, Sentinel functionality is available to all of our enterprise customers. It's not available at any extra cost. It's there in the products, and it'll be there. Pretty much the betas are going to be there today. We're hoping that the final production release is going to be around 4 weeks or so. And I think Sentinel's really easy to use. I've been spending a sort of a week or so working on the policy, and it's actually been a pleasure to use. I mean, I'm a Go programmer, and I've really enjoyed writing Sentinel. I kind of think I'd like to write Sentinel in my day job. But it's a simple language, and it's optimized for readability. It's embedded inside of that execution path. It stops things. It's not warning you, and it's not kind of doing any retrospective. It's not going to allow you to do what you're trying to do if you're outside a policy. It doesn't allow you to do any unsafe operations. You can't write policy which does any sub-process execution. That's completely banned. And the Sentinel Simulator is easy to use. It encourages that approach to kind of test-driven policy. And of course, it's fully CI and CD compatible. So if you want to know more, Jeff's going to be doing a talk tomorrow, Security and Fundamentals, and he's going to be doing a bit more of a deep dive on how Sentinel and Vault work together. I want to thank you so much for your time. I want to thank you for coming to HashiConf, and thank you so much again. Thanks. Do we have any time for questions?
I think we've got time for
one question. Oh, well, we have a winner.
I'll make sure that I raise my hand first. Quick question about the code coverage. When you run the test, right, how do you make sure that your test cover all the policy defined in your Sentinel file?
So the question is...
Can you repeat that?
Yeah, of course. So the question is, how do we ensure that we've got code coverage in our tests? So at the moment, you have to do it by hand. So at the moment, you have to manually ensure that you've got code coverage. Now, the Sentinel Simulator is literally hot off the presses. So we're adding features to enhance the readability, the usability of it as things move on. We're looking at things like composing the test files in HCL, which people might find more easy to use. And code coverage is a really great one. We should be able to see that all of the elements of our test are covered there. So unfortunately, you can't right now, but I think we'll build that feature. That's a good one.
Okay, thanks again, Nick.
Thank you.